was it just due? It's due. Yeah, it was due yesterday. And then you can respond to however many people I put by tomorrow night. Is there any questions on that though? You both got it done? Okay. There is a new lab that I'm going to put up. Probably sometime today or tomorrow. Share. So project 5, I don't know why I called it a lab, probably because we were talking about labs, but the project was due last night. And then you need to respond to at least, I think it was 3 people by tomorrow night. And if for some reason you haven't gotten it in or it slipped your mind, just get it in as soon as possible this week. Because the next project will be going up today or tomorrow. But it's 55 points. The main post will be due April 21st, and then respond to at least 3 people by April 23rd. This one works with carrying capacity, which we had on our last exam. And just, it's up to you. I thought it was kind of interesting because I was finding different carrying capacities for things when I was making up the exam. So you could choose something of interest to you or a favorite animal. It could be a plant, it can be the human population, it can be coal, iron, anything that you want in a certain area, and use that carrying capacity. Create a PowerPoint. What is the carrying capacity per unit? Like the one you had to do on your test was the deer. There was, I think it was 20 deer per square mile. Yeah, white-tailed deer have a carrying capacity for 20 per square mile. So choose an animal or anything in your area. It could even be population. You could do population for your community, population for your state. What area are you doing the project on? So for the test, when we did the carrying capacity, the area was Mill Creek Park. So then I found, or you found, the carrying capacity for the area. How many deer should be in that area? Is the species overpopulated or endangered? Ours was overpopulated because I think this was 180 and this was 3,000. But some of them are endangered. Panda bears are, well, they were endangered. They're getting better now because they're breeding them and then setting them into the wild. What is being done? So that would be the panda bear one, or could be done. So are they doing anything about the overpopulation or the endangerment? Or what could they do? Include at least 3 pictures. So you can show a picture of the area, a picture of the animal, or plant. It can also be plants and people and just about anything. Why'd you choose this topic? A reference page, so wherever you got your information from. Respond to at least 3 classmates. Creativity rather than my examples. And turn it in on time. Any questions? Positive. So it's not due till April 21st. So, I mean, you have a break on Friday, and if you celebrate the holiday weekend, you can wait until the following Monday. But I just thought if people wanted to get things done, because I know it's getting close to the end. Any questions? So we are in this week here where we're covering chapter 5. We'll probably cover most of 5.2, I think, today. And project 5. We'll cover chapter 5 and 6. And then, well, chapter 7, I just take the things and put it into the project each time, because chapter 7 is kind of a project section or looking at things further, different case studies. So I take the best parts for each. And so there'll be one more project. Project 5 is due the 21st. And responses the 23rd, and then this one will come up and it'll probably be due the 1st, and then responses by the 3rd. So it'll go up sometime the end of this week. Your final is Wednesday, May 10th from 8 a.m. to 10:30. So we're done with our exams. If you turned them in on time, the take home, or did the in-person, the grades are there. If you didn't, please get it in as soon as possible. And if you don't have a time set up for the in-class, please email me. Any questions?
What will the final be on the 10th?
The final will be similar to the other 2 exams. I mean, not the material, but the items. It'll be over chapters 5 and 6.
Okay. So it'll be like a test.
It's like a test, yeah.
Okay.
Yeah, I don't see a need to make it cumulative. So it'll be similar to 5 and 6. We will review just like we always review. And did you like having the take home and the in-person, like the 2 parts? And
yeah.
I did.
Okay, so then we'll set it up just like that one where you have part of it take home, part of it in person, and it will probably be due May 11th. So the take home will be due May 11th. The in-person though is May 10th at 8 a.m. So be careful, it's not our regularly scheduled time. And it will not be a 2.5-hour exam. It will be the same length as your other ones. So it shouldn't take you more than an hour. Any questions?
So we have to actually start at 8 a.m. or?
Well, that's when the test starts. If you come in later, you will have plenty of time because it will not be longer than the 1-hour exam. So even if you came in at 9 when our normal class is, it would be fine. Any questions on that? .2 is probability. It's my favorite section from statistics, but it's not everyone's favorite section. I like to look at gaming and probabilities. Any activity whose result cannot be determined with certainty is a random process. An outcome is a result of a single instance of that random process. Now, one thing that cannot be determined with certainty is the weather. My husband always says the weatherman is the one job that you never have to get right. And it's not, it's probably not their fault. But the weather is an example of a random process. We cannot perfectly predict the weather from day to day because of all the different things that can change it. It's too complex a process. That's why the weather forecast usually is a range of values. The low's going to be 45, the high's going to be 69. Yesterday, I think we had a high of 60. Today, it's supposed to be a high of 80. So they're definitely guessing in there. And then tomorrow's a high of 54. But we have a storm coming in, supposedly. And that's why they use ranges of values. It might say a 20% chance of rain. So then you might decide, well, we're supposed to have a family reunion. We're still going to go 20%, not very likely. But if there's a 60% chance of rain and they're doing road work because the trees fell on the road, they may put it off, especially with the power lines. And so knowing a percentage, now when they say 20% chance of rain, what that means is in that area, 20% of it will see rain and 80% will not. So it doesn't mean there's a 20% chance, say it was at Appalachian State. If they said there was a 20% chance of rain in that area, Appalachian State University, 20% will see rain, 20% section. So it's not the people, it's the section of land. So if they're talking about just your college and they say there's a 20% chance of rain, it should rain on 20% of the campus. So that's what they mean by that. So 60% means more than half of campus will get rain. Any questions on that? Another random process is slightly different. The scientific method. Now, this example, I think it's a pretty good one to understand it. Imagine a scientist carries out an experiment to measure some quantity, perhaps average concentration of arsenic in the water in a lake. So kind of like we had that explosion with the train and it got into the water. They could take a sample. But if they only take one sample, are they really finding how much is in the lake? Depends on where that sample was. And so to be a good scientist, you need to take more than one sample. So it's a random where you grab your sample, and like one could be where there's fast moving water so that the arsenic is flowing away quickly. Maybe it doesn't have as much. But then there could be another one where, depending on, there could be a rock that's blocking water and making a puddle or a slow moving area. Then there could be a lot more concentration there. And that's why you have to take several samples in different areas to be able to get an idea of how much is really in that lake. Carbon dioxide's the same way. They tell you, like the smoke detectors and carbon dioxide ones together, they tell you certain areas to put it in. Like you don't want to put it in a hallway that's all closed in, because then you turn your stove on and if it's near that hallway, it's all gonna bundle up there. If you think about when you cook the next morning, like you walk down the hallway and it might be right there. Ours is at the steps. When I open the door to the steps, it's just sitting right there. So that air is not moving. It's going to give me a different reading than an area that's wide open. And so that's why you need to do several different samples in different areas. Any questions on that? Now, once they do all those different areas, they obtain one value that they feel is best. Maybe they average them all together. If they got several high readings and maybe only one or two low readings, then they only use the high readings, or vice versa. That's called an inference. So they're looking at what they found and they're applying it to the whole. And we do that in a later section. But it's called an inference. They imply what it means or imply it to the whole. But it's not just one sample, it's several. Any questions on that? I thought I had them all over here. A third example that your book uses is games of chance, where the first random process to be studied by mathematicians in the 17th century. You can flip a coin or several coins, rolling a die. Examples of random process for which we can write down the complete list of all possible ones are called, they're called the sample space. What's more, if the coins or die are assumed to be fair, what fair means is like when you roll a die, it's equally likely to land on 1 through 6. If you toss a coin, a head or a tail, it's equally likely. Equally likely means it has the same chance of landing on those values or heads or tails. Now you can also have what's called a weighted die or a weighted coin, and it lands on one section more than the others. But to start with, we're going to assume they're equally likely. I don't think there's anything else in. They're gonna, I'm not sure why, but we're gonna find examples on the next few pages before we get back to sustainability questions, because they want you to see the theory behind it. And I think games of chance are fun. So the sample space, which I underlined up here, is an exhaustive list of all possible outcomes. It's usually denoted by the letter S and is written using set notation. The list of possible outcomes is enclosed by curly brackets. So if we want to look at the sample space when you toss a coin, they'll use an S for sample, and then they use the script parentheses. And then you just list your possible outcomes. If we toss a coin, we can have a head or a tail. If we roll a die, assuming it's a 6-sided die, because there are dies with more sides. We roll a die, we could have a 1, 2, 3, 4, 5, or a 6. So sample space, the reason they say exhausted is you're listing every single possible outcome. What if we toss a coin and roll a die? That would be a head with all of these and a tail with all of these. Now, to make sure you get your whole sample space when you're doing more than one thing, tossing a coin has 2 possibilities. Rolling a die has 6. So my sample space should have 2 times 6, which is 12. One way of making sure you got them all. So whenever you have to find a sample space and you're doing 2 things, as long as one doesn't rely on the other. For instance, if you pull a card from a deck, but then you don't put it back, it's going to change your probabilities. And it's going to change that. But when these 2 do not rely on each other, we get into that in another area, but that means they're independent of each other. You can use this process. So if we toss a coin and roll a die, we should have 12. head with a 1, a head and a 2, heads 3, heads 4, heads 5, and heads 6. And then we can have tails. Tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6, which is 12. Any questions on sample space? An event is any collection of outcomes, that is to say, any subset of the sample space. E is what we're wondering if it will happen. On some play of the game is the same to say the outcome of that particular play. Here's examples of an event. They could say the event of rolling a number less than 4, less than or equal to 4. Less than or equal to 4 would be 1, 2, 3, or 4. Because rolling a die has these possible sample spaces. Less than or equal to 4 would be 4 or less. So 1, 2, 3, or 4. If event B is rolling an even number, we'll look at our dice again, an even 2, 4, 6. And one more event, C, it's rolling anything but 4. If we're rolling a 6-sided die and we don't want a 4, it would be all the values except for 4. And that's how I got 1, 2, 3, 5, and 6. So event is just what you're expecting. It could even be, an event could be rolling a 5. It doesn't have to be more than 1. It could be, if you're tossing a coin, the event could be heads. Any questions? Now let's also talking about 2 extreme examples. The event of an empty set is when it's none of the outcomes. So maybe we would say if we're rolling a 6-sided die, the probability of rolling a value greater than 6. There are not any greater than 6. And so that would be your empty set. Something, an event that doesn't include any of them. Or you could have it include all of them. The entire sample space containing every outcome. The probability when you roll a 6-sided die of rolling a value greater than or equal to 1. That's all of them. So that's why they call it an extreme. One doesn't have any of them, one has all of them. Any questions so far? Definition for probability. The probability of an event is a real number between 0 and 1. When you're looking for probabilities, your answers should be between or including 0 and 1. So it can equal, notice we have here the equal to. So a probability is a value between 0 and 1. How likely the event is to happen. If E is an event, its probability P of E is between 0 and 1. You can write your probability as a percent, a decimal, or a fraction. So we could say, like they had here, 25%. 25% as a decimal, 0.25. As a fraction, tens, hundreds, 25 over 100, or 1/4. So when you're giving a probability, if it doesn't specify, you can write it as a percent, a decimal, or a fraction. Any questions? Probability model. It's a mathematical representation of a game of chance. It is defined by the sample space made up of all possible outcomes, the events which the collection of outcomes or subsets of the sample space, the probability associated with each event. So sometimes they put it in a table. Okay. If we're rolling a 6-sided die, and well, we did put the sample space also. Our sample space then would be the numbers 1 through 6. Now, if we assume it's a fair die, it could end up on any of these equally likely. The probability to roll a 5, there's 1 5 out of the 6. 1 6. Probability of an even 2 4 6. So there's 3 out of the 6, or 3 6. And I'm not worried about reducing. These ones I would probably leave the fraction rather than having a repeating decimal. But 1/4 you can write as 0.25. Whereas if you take 1 divided by 6, you're going to get 1.66666, or 16.6%. So that would round to a 7 if you rounded. So when they're ones that keep repeating, I usually use the fraction, because then I have the exact value. Rolling a number less than or equal to 4. This says it's including the 4, less than or equal to, so that would be these 4 numbers, 1, 2, 3, or 4. So there's 4 of them out of the 6. What would be the probability of rolling a number more than 4? Anyone?
2/6.
Yeah, because there's 2 of them that are more than 4 out of the 6. Probability greater than 6. Well, how many values in the sample space are greater than 6?
None.
None of them. So it's 0 out of the 6, which is just 0. If we look at this one, how many values in the sample space are more than 0?
6.
All of them, all 6. So 6 out of 6, which is just 1. So you could write it as 1, or you could write it as 100%. Any questions on that? Law of total probability. in any probability model with a finite sample space. Finite means you can actually write them down. The sum of the probabilities of all individual outcomes need to equal 1. Outcomes in a probability model are said to be equally likely if they have the same probability. If all outcomes in the sample space are equally likely, then the model is uniform. So what that means is if we look at the rolling of the die, and make a table, we can get a 1, 2, 3, 4, a 5, and a 6. Then we can find the probability of each of these. The probability of rolling a 1 is 1 out of the 6. Well, because it's not a weighted die, they're all the same probability. The probability of a 2 is 1 out of 6. 3, 4, because there's only 1 of each, and they are all equally likely because it's not a weighted die, it is a fair die. Notice though, if you add them all up, you're going to, if you add all of those up, you'll get 6 over 6, which is 1. Your probabilities need to add up to 1. When you take each individual one, the probabilities have to add up to 1. If we toss a coin, when we talked about the sample space a little bit ago, we can get a heads or a tails. What is the probability of tossing a heads if we toss it one time? Anyone?
1/2.
1/2. Yep. How about a tail? 1/2. Do they add up to 1? So whenever you have to make a table with your probabilities, as long as you can list all the probabilities or the sample space and find their probabilities, they need to add up to 1. 1/2 plus 1/2 is 2 over 2, which is 1. So the probabilities of a sample space will add up to 1. Any questions? Equally likely probability rule. When all outcomes in a sample space are equally likely, we just talked about that. As long as they're equally likely, it's how many there are divided by your sample space. And that's what we were doing up here. Just count out how many there are and divide by the total number in the sample space. Do an example of tossing 2 coins. So if we're tossing 2 coins, when we toss the first one, heads or tails, so 2 possibilities. When we toss the second one, again, there's 2 top possibilities. So we should get 4 outcomes. Find the sample space, and we're just going to first keep track of what we rolled or tossed. So we could get a heads on both of them. We could get a head or a tail. And then we could get tails first and then heads. So those are different. Think of them either tossing them separately or two different coins. And then two tails, because we need to have 1, 2, 3, 4 items in our sample space. A head and a tail. Is this different than a tail and a head? If instead of listing heads or tails, what if we want to list how many heads were tossed when we tossed two coins? What's our possible outcome if we're counting how many heads are tossed? We could have,
4.
I think there's only 3. Because we could have, here we'd have 2 heads. These two give us 1 head. And this one gives us none. So we have 2, 1, or 0. So if we're counting, you toss your coin twice and you count how many heads you have. And you could have 2. These 2 give us 1 heads, and this one gives us a none. So then when you're finding your probability, you either want to write this or be thinking about it. To get 2 heads, there's only 1 way out of the 4. To get 1 heads, there's 2 out of the 4. And I wouldn't reduce that. I'll show you why in a second. To get none, that would be this case, 1 out of the 4. Notice that these will add up to 4 out of 4, which is 1. And that's why I wouldn't reduce this, because to add them and check your answers, you want the same denominator than you add across the top. Any questions on that? Two heads, there was just this one. 1 head, there was 2 of them out of the 4. And then no heads was 1 out of the 4. So sometimes writing this sample space before you do certain ones that they're looking for helps. Any questions on that? One, two, done. Let's stop there. This one takes a little more time. Now you could think about the sample space and look up the possibilities when you roll 2 dice, but we'll do this one. We'll start with this one on Monday because there's no class on Friday. Is there any questions? If you do not have any questions, have a nice week, rest of your week, and I will see you on Monday.